1.4 is quadratic equations. All right, so the first problem say to solve each equation using the zero factor property. So that is the first thing that should have been in your notes. So basically we're just factoring and then setting each piece equal to 0. So 16, got 2x squared minus x minus 15 equals 0. So we need to factor this by the arch method. So I need factors of 2 and negative 15, so negative 30, that add up to give me negative 1. Six and 5, so 5 is going to be a positive and 6 is going to be negative. So then 2x squared minus 6x plus 5x minus 15. And then factor by grouping. So take out a 2x. So that's x minus 3. Take out a 5, x minus 3. So then I've got 2x plus 5 times x minus 3 equals 0. And now this is where technically the zero product property comes in. We take each piece and set it equal to 0 and solve. So 2x plus 5 is equal to 0. X minus 3 is equal to 0. So 2x is equal to negative 5, or x is equal to negative 5 over 2, or x is equal to 3. Another example of that, number 22. Got 9x squared minus 12x plus 4 equals 0. So arch method again. So I need factors of 9 and 4, or 36, that add up and give you negative 12. Yep, negative 6 and negative 6. So 9x squared minus 6x minus 6x plus 4 equals 0. Factor by grouping. I'm going to take out a 3x. So that leaves me with 3x minus 2. Then on this one, I need to take out a negative with it because I know that the sign of the 4 is going to need to be negative to match this one. So I'm going to take out a negative 2, which gives you 3x minus 2, excuse me, is equal to 0. So then I technically have 3x minus 2 times 3x minus 2, so I'm just going to put a squared thingy on it. And so then since that's being done twice, I don't need to do it 2 times up here because it's going to, like I did up here, because it's going to be the same thing. So I just need to do 3x minus 2 equals 0, because the squared is just going to go away. If you take the square root of that and the square root of 0, you still have 0 on that side. So then 3x equals 2, x equals 2 over 3. All right, the next one say to solve the equation using the square root property. So remember, when we take the square root in an equation, our answer is what? Or how many answers do I have with the square root? 2. I have a positive and a negative one. So start with an easy one. 26x squared is equal to 121. So if I take the square root of that, my answer would be what?
11. And negative 11.
Yep. X equals 11 or negative 11. And if you want to just write it as plus or minus 11, that's fine too. So then if we have one like 34, and I'll say sometimes too with these problems, they might give you something that isn't like directly like a perfect like square or whatever. So you would just need to factor stuff out like we did. I think it was in the last chapter. We had some stuff where we had to factor it out like that. 34, x minus 4 squared is equal to negative 5. So when I have something like this, the first thing I need to do is take the square root of both sides. So on the left, basically just undoes the square, so I'm left with x minus 4. Then I have to take the square root of the right side, so I'm going to go ahead and put the plus or minus. So plus or minus the square root of negative 5. Now, what's the problem with this? It's negative, so what do I need to do? Yep. So it would be what?
Negative. No. 25i. I'm right.
Not 25. So when we have a negative under the radical, we just take it out and we put it out front. So it would be plus or minus I root 5.
Oh, yeah, we're not using 25.
And so then x equals 4 plus or minus I root 5. And I don't know, maybe you are, maybe you're not thinking, well, when we did standard form in the last section, I had to put the I at the end. Technically, yes, the I should be at the end, but it gets confusing sometimes and it looks like it's under the radical, so most people stick the I in front of the square root. So totally fine. It doesn't specify that it has to be standard form, so I don't care. All right, the next thing I will say tends to be probably the most confusing for people. It's completing the square. I assume you've probably seen it before, but more than likely it hasn't made sense, and it may still not make sense. The pre-cal group the other day when we were doing it was like, I finally get it. And it's like you see it in Algebra 1, you probably saw it in Algebra 2, and it's like the third time around, it finally made sense. So we're going to complete the square. My phrase for completing the square is, or what I'm going to say over and over again is half the middle term squared. So the middle term is our x term, and that's what has a number with it. So 38, we have x squared minus 7x plus 12 equals 0. So now, really fast, to complete the square, there has to be a 1 in front of x squared. If there's not, then you've got to divide the whole thing by whatever's in front of it, which really just gets annoying. When I give problems on like the test and quiz and stuff, I try to give problems that have a 1 in front, but that may or may not always happen. So I need to move this 12 over to this side, and then I'm going to add a box here and a box on this side. So just to save us separating, I'm going to do this all in one step. So x squared minus 7x is equal to negative 12. And I usually draw my box in a different color just so that it's evident what's happening. So the boxes on both sides just comes from whatever you do to one side, you have to do to the other. So we are going to take this number, okay, and it's always going to be positive over here regardless of what the sign is here because it's getting squared. So half of 7, okay, you can either think of it as 3.5 or 7 over 2. I'm going to do it as 7 over 2 for right now, and you'll see why in just a second. It doesn't really matter, but it'll work out kind of nicely. So 7 over 2 squared. Now when I write it over here, I'm going to go ahead and actually square the number. Okay? So this is going to be 49 over 4. So if you're wondering why I did it that way, the goal on this side is that we get a perfect square trinomial. Okay, and so now that's what that has allowed us to do. So by leaving it this way, I know what I'm basically putting in. So I will have over here x minus, 'cause that's what the sign is, and then 7 over 2, and the whole thing squared, is equal to, I'm going to go ahead and rewrite negative 12 as something over 4 just so that I don't have extra writing. So this is going to be negative 48 over 4. And I don't mind if you do that just to, save some writing. So that leaves me with, if I add that together, negative 48 over 4 plus 49 over 4, I just am left with 1/4. So then now, once you've done that step, you're back to either you're going to be at a point where you can do the zero product property, first, I guess I should say, you're going to do the square root property, which is what we just did in these last problems. Okay, we're going to take the square root of both sides. Then you'll be back to it's not zero product property. Then you'll just be in basic algebra at that point. So, square root of both sides, we have x minus 7 over 2 is equal to plus or minus, what's the square root of 1/4? What's square root of 1? Okay, so 1 over, what's square root of 4?
16.
Square root.
Oh, 2. Yeah, 2.
So remember, when you have the square root of this, it can be written like this. So if you need to think about it that way. And we still couldn't have a square root on the bottom when it's all said and done. So if we had ended with a square root on the bottom, we would have needed to rationalize it. So that ends up giving us that. That's how we get there. So then I just need to add this 7 over 2 over. I'm going to go ahead and split this because now that I have an actual number here and not something left under the radical, I need to actually get the two answers. So I'm going to have x minus 7 over 2 is equal to 1/2, or x minus 7 over 2 is equal to negative 1/2. Are we tracking on that part? So then add the 7 over 2, so x is equal to 8 over 2, or x is equal to 4. And then on the other one, x is equal to, add that, so 6 over 2, x is equal to 3. So x equals 4, or x equals 3. All right, I'm going to show one without a 1 in front just so that you see the process of what you would need to do in case you end up with one like that. 44, we've got 3x squared plus 2x is equal to 5. So when I'm writing it, I always go ahead and leave room so I can go ahead and put my boxes there so I don't have to rewrite it. So if you like rewriting it, that's totally fine, but I'm all about as little writing as possible. So I'm going to I'm not even gonna, I'm gonna go ahead and show that I'm adding my box, but I'm not gonna be writing anything in the box just yet. So I have this problem where I have this 3 in front, so I'm gonna divide the entire equation, so both sides, by 3. Okay, so I'm going to divide this by 3. And the boxes are just there as a placeholder because eventually when I do half the middle term squared, then we'll be filling it in. So now I have x squared plus 2/3 x plus box is equal to 5/3 plus box. So half the middle term would be what? What's half of 2/3?
1/6. No. I'm horrible for 2/3. Half of 1/3.
Yep.
Okay.
So 2's cancel, so it's 1/3. So this is going to be 1/3 squared. My box isn't big enough. Let me make it bigger. There we go. And then over here, I'm going to go ahead and make this 1/9. So now on the left side, I have x plus 1/3, and then the whole thing squared. Now 5/3, I'm going to go ahead and rewrite that as, I'm going to multiply that by 3/3 so that I get a common denominator of 9. So that's going to be 9 on the bottom and 15 on top. So that's going to give me then 16/9. Take the square root of both sides, what do I get? Or like, what do I get on the right? What's the square root of 16/9? 4/3. And we're going to be plus or minus 4/3. These are nice. They give us perfect squares. So then I'm going to go ahead and split it again. So x plus 1/3 equals 4/3, or x plus 1/3 equals negative 4/3. So I've got x is equal to, so I'm subtracting that, so 3/3, or x is equal to 1. And then on the other one, subtract that, x is equal to negative 5/3. And I can't reduce that, so. Any questions on completing the square? Is at least ringing a bell. Let's see. All right, solve the equation using the quadratic formula. Anybody know the quadratic formula off the top of their head?
I think so. Wait. Does it start with negative, right? Negative b minus plus.
Which one? Or is it both?
Plus or minus, right? 2a? No, it's over 2a, but something in the end is 4ac. And it's like in the square root thingy. And there's something right there.
You're missing something here and a sign.
B squared plus 4ac? Minus 4ac. Is that it? How would we got into it?
Yeah. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You used to have a poster up in here with it, but I think it fell down and I didn't put it back. I don't know where it is. It's orange, I know that. But I don't see it. It is MIA, apparently. All right, so these problems, they give us like 58. Negative 6x squared is equal to 3x plus 2. So, obviously we need everything on one side. It doesn't matter which side I move it to, but I like to not deal with negatives, so I'm going to move the negative 6x squared over. So 0 is equal to 6x squared plus 3x plus 2. And then we just plug it in and reduce it down as much as possible. So negative b, so that's negative 3 plus or minus the square root b squared, so that's 3 squared. And if you want, like, knowing that's 3 squared to go ahead and write that as 9, you can. But just for this first one, I'm going to go ahead and write out each step. Minus 4 times a is 6 times c is 2. All over 2a, just 2 times 6. So then negative 3 plus or minus the square root of 9 minus 48.
Or negative.
Yeah. 9 minus 48 is negative 39, I think. So then I've got negative 3 plus or minus the square root of negative 39 over 12. What's the problem here?
The negative inside the negative.
So what do I need to do?
Do the I thing.
Yep, so negative 3 plus or minus I root 39 over 12. Can anything come out of 39?
3 and 13.
So I have to have two things to be able to take it out. So can I take anything out of that? No. So I would just leave it like that. Now, some people, this is what not to do. Some people say that, I'm just rewriting it over here. Some people decide that then this is 1 over 4, so then this becomes negative 1 plus or minus I root 39 over 4. It's false information. Can't do that. Okay? Because of this being plus or minus here, we can't have this. Okay? We would have had to have something here that could also come out for us to be allowed to do that. So, don't do that. Hopefully y'all wouldn't have done it anyways, but I like to point it out because nonetheless it happens very often. Do we need to do another quadratic formula, or are we okay?
I'm good.
I don't mind if anybody feels like they need it, but since it's just plugging in, usually people tell me just to do one. Solve the equation for the specified variable. So we've got 74 capital E is equal to a lowercase e squared times k over 2r. And it says to solve for lowercase e. So any idea how I do that? I want to get little e by itself. Multiply by 2r. So I've got 2r capital E is equal to e squared k. So then what? I want this by itself. Divide by k. So 2r capital E divided by k equals e squared. And what will my last step be? Square root. And that gives me what on this side then? Or what do I need to put in front of the square root? What have I done on all these other problems when I took the square root? All the way up here.
Oh.
Plus or minus. So anytime you're taking the square root of like both sides of the equation, you're always going to have plus or minus, even if it's just variables. All right, the next thing say to evaluate the discriminant for each equation, then use it to determine the number of distinct solutions and tell whether they are rational, irrational, or non-real complex numbers. So hopefully you have this chart in your notes because that's what you're going to need to be able to do that. So 88, 2x squared plus 4x plus 1 equals 0. So when it says to look at or to find the discriminant is this part of the quadratic formula, the b squared minus 4ac. Did I not write? Oh, I was like, I swear I wrote 88 down. Where'd it go? All right, so b squared minus 4ac. So I'm just plugging the numbers into that. So that's going to be 4 squared minus 4 times 2 times 1. So that's going to be 16 minus 8, which is 8. So go over to my chart. So I got a positive number. Is 8 a perfect square? Like, does something squared give you 8? No, because 2 squared is 4, 3 squared is 9. So I go to my chart, and so the discriminant is positive, so it's one of these two. Not a perfect square. So there's 2 solutions, and it is irrational. So we would say, so the answer to this, so they want you to find this number, then they want you to say positive, not a perfect square. So irrational. Oh, and 2 solutions. All kinds of stuff they want you to have. I guess technically they're looking for irrational 2 solutions, but it's good for you to explain why, because when you get to a quiz, test, whatever, then I can see if you write the wrong thing, I can see where you went wrong. All right, one more, and then we'll be done, because I know this has been a lot. All right, 3x squared is equal to 4x minus 5. So before I can do the discriminant, I've got to get everything on one side. So I'm going to move the 3x squared over. So 0 equals negative 3x squared plus 4x minus 5. So then b squared minus 4ac. Got 4 squared minus 4 times negative 3 times negative 5. So I've got 16. And then negative 4 times negative 3 is positive 12 times negative 5 would be negative 60. So 16 minus 60 is negative 44. So then, where did my chart go? Come back. There it is. So it is negative 44. So the discriminant is negative. Means there are 2 non-real complex. So we would write negative 2 non-real complex solutions. and I don't know if I've told y'all this before, but SOLN or SOLNS is just for a shortened way to write solution. So, all right, I'm going to give you your problems. You're going to have time in class tomorrow to work on them. So this is 17, 35, 37, 43, 57, 73, 89, and 91.